in a well. So what is the average value formula? So for example, I average is equal to 1 by T into 1 by T 1 by T integral 0 to T. So integral 0 to T I of T into dt. This is called average value, and RMS value IRMS is equal so 1 by T integral 0 to T I square of T into dt. Okay, so square root. Okay. So this is the formulas for to find the IRMS and I average. Okay, for example, V average is equal to 1 by T integral 0 to T I V of T into dt. VRMS is equal to under of 1 by T integral 0 to V square of T into dt. So by
Sir,
using this formula, sir, you will get the answers.
sir,
Tell me.
sir.
So for this triangular waveform, I square RMS is equal to 1 by third into this. I square means 200 square into the time period 4 divided by total time period 0 to 4. So this is the time period. And then, so 200 square divided by 3. Then IRMS is equal to 200 divided by root 3. Am I right? For this triangular waveform. Okay, by using this formula, so we'll get easily, okay, IRMS values. IRMS and IRS. It's clear. So another waveform, I will give another waveform. Can easily understand the concept. So the understood? This is called I of t. This is called time period t. This is 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. Like this. Here plus 10. 10 amps. Plus 10 amps. Here, so minus 10. So find I average and IRMS. Okay, for this waveform. So I average is nothing but first find the area of this. Okay, and then after that area of this. Total time period is called 4. It's clear. Total time period is nothing but 4. So how to find the average? I average is equal to I average is equal to, for triangular waveform, what is the average value? Half into area covered by triangle. So 2 this length. Okay. Into height. Okay. Plus area covered by this square, no? So L into B is called area covered by this. So what is the length? 2, and this length minus 10 divided by total time period. That is called 4. Understood? Then how much? Minus 5 by 2. That is equal to minus 2.5. This is called I average. Then how to find IRMS? IRMS square is equal to first this is triangular. For triangular, triangular or sawtooth. So what is that formula? 1 by third I square into T divided by total time period. So 1 by third into I square. I is nothing but 10. Square into time period. 0 to 2. So this is over. And next for square, this is first and this is second. For second square, so what is the for case square type? What is the RMS value? I square into T divided by total time period. Understood? For square type, so minus 10 whole square into time. Up to what is the 2 to 4? What is the time period? 2 now. So 2 divided by. So what is the total time period here? 0 to 4. Okay. So you will get IRMS is equal to, simplify this expression, you will get 5 root 3. So in this way, you have to find IRMS and I average. For square, 1 by third of I square into T divided by T. For triangular or sawtooth. Okay, for square type waveforms, I square into T by T. Simply by using these formulas, you will get the answers. Okay, without using these equations. Any type of waveforms. Okay. So 5 root 3, the approximately equals to 8.165 amps. Understood? And take another example. Can easily understand the concept. Let's take another waveform. So this is the waveform.
Sir,
Hmm.
so for triangle, how do we calculate half cycle and full cycle?
Okay. So for average value,
Average 0, no, sir.
so average year to year, calculate year to year. This is the waveform is repeated. No? 0 to 4. Okay. 0 to 4, the waveform 0 to 2 and 2 to 4. This is the one waveform. Again, the waveform is repeated 4 to 6 and 6 to 8. Okay. That's why you have to find average value. So 0 to 4 and 2 to 4. If it is waveform is started here onwards, so 0 to 2 is enough. So for this waveform, 0 to 2, 0 to 4. Okay. This is the time period. Again, 4 to 8 repeating. That's why don't include time period, total time period up to 0 to 4 only. Okay. So if we repeated waveform, na, 0 to 4 is okay. And 4 to 8 repeated. Repeating the waveform. That's why don't include this waveforms. Up to 0 to 4 only is required. Okay. So that's why here also 0 to 2 is waveform and 2 to 4. And repeating again 4 to 6 and 6 to 8, the waveform is repeated. That's why find up to only 0 to 4. That is called total time period is nothing but 4. Okay. So here, what is the total time period? So 0. So here 1. So here 2. And here 3. So here 4. So 5. 6. Understand? So here 5 amps. This is called, for example, I of t. So this is a triangular. So to find, so it is having 3 regions. So for this, find the average in this region. First one, second one, and third one. So what is the total time period here? So up to 0 to 3. 0 to 3 only the time period. It's clear. 0 to 3 only the time period. So because of after 3 onwards, the waveform repeating again, same way. 3 to 4 and 4 to 5 and 5 to 6. The waveform is repeating, so on like this. That's why, so the total time period is nothing but 0 to 3. So then I average is equal to, what is the I average here? First triangular waveform, half into L, 1 into height, 5. Okay. Second scale. So 1 into 5. Then third triangular wave. So same, half into, so 1 L into height, same 5 amps. Divided by, what is the total time period here? 3. It's clear. Then you will get answer 10 by 3, approximately 3.33. Okay, this is called I average. And then IRMS. IRMS, scale, how to find IRMS? For this, so 1 by third into I square into T, no? I square is nothing but 5 square into T. Time is period 1. Then square, first one is over. And then second one, L into B. So 1 into 2. This is for square. Second one. And then third one, similarly. 1 by third into I square. So 5 square. 1 by third into 5 square into 1. So divided by, what is the total time period? 3. Then you will get IRMS is equal to, RMS is equal to, so approximately root 50 divided by 3. This is the IRMS value for this waveform. It's clear. And then next, for this problem also, find the IRMS and average value. Yeah, 5. So your time period 0 point taking 0.01, here 0, 0.01 and 0.02 and 0.03 and 0.04 and 0.05 and then here 0.06. So tell me, what is the time period here? What is the time period here? 0.02 or 0.03 or 0.04? Time period T. Anyone? What is the time period
Two,
for
sir.
this? 0.02?
0.03.
0.03 is right. So because of 0.2, 0.3, 0.03, this is the waveform repeating again up to here. And again, this waveform again it will start from here onwards. Okay, so like this. Up to here. So 0 to 0.3 is the time period. Okay, so for this waveform, so I average is equal to similar way. So half into L into B, half into L into height, length into height. So half into, so area, half into. So for this, the 3, half into 0.01 to height 5 amps. Similarly, here also 0.01 into 5 divided by what is the total time period? 0.03. So in this way, you have to find. Okay, this is for average value and RMS. I square RMS is equal to for area for scalar for triangular 1 by third into I square into T. So I square is nothing but 5 square into T. What is the time? 0.01. Second one, square. So I square into T. I square is nothing but 5 square into T. So that is called 0.01. And then third, so there is no area that is called 5 amps here, 5 amps now, that is called 0 amps. That's why third is equal to 0. But what is the time period here? 0.03. Okay. For this IRMS is equal to 3.33 amps. For this IRMS is equal to 2.5 approximately. So it's clear. Is it clear, everyone? How to